Hello, today we'll be talking about limits. So, what is limits? Well, the limits is one of the core of the calculus, and it is also limits that separate calculus from pre-calculus. So what is this? Well, there's a keyword for the term limits. It's this approach. And the whole concept of the limits is that how would a function the output of the function behave as the input approaches some particular value? Well, we've already seen this in pre-calculus actually, the approach. Let me show you. So here's a function, y equals 1 over x. It's a rational function, and it looks like that. And we're going to focus on its domain, which is x cannot equal 0, because when it equals to 0, it will just be undefined. So let's take a closer look here. We can see that the function gets really close to y-axis, but it never actually touches it. Therefore, we say this as x gets to 0, y gets to infinitive. Also, we see that when x equals to 0, there is no y value because it's just undefined at that point. So it's pretty similar when it comes to calculus. So let's take a look at this function. We can easily see that its denominator x minus 3 cannot be equal to 0. Therefore, x cannot equal to 3 because at that point it's undefined for this function. So let's take a look at its graph. So we can see that at first it's all nice linear graph, but at this particular point, which is x equals to 3, there's a hole in it, like a white hole, because there's no value in it. So when x equals to 3, the value of y would be undefined. So there's a hole in it, a blank hole. That is a basic idea of what a limited function looks like. A certain value is taken off or moved to another place. So we can see that as x gets to 3 and y gets to nothing because it's just undefined. And after that particular point, it keeps going like a nice smooth linear line. So that is a basic idea of graph. We can also look at this by a chart. The same function, and we know that x cannot equals to 3, but let's see what will happen when x gets to 3. Okay, so let's take a closer look at this chart. When x is 2.9, y is negative 0.1, which is okay, and it's 2.99, it's just gets more precise, and the same stuff. The third one is okay, and the fourth one is okay. But when it gets to 3, it becomes a sad face, which is undefined. The y value is not exist at that point because its denominator, we can see that it's 0. 3 minus 3 equals to 0, which is not okay. So as x gets to 3, and the y becomes undefined. That's basically what this chart tells us. And after that, if we take a closer look here, we can see that after x equals to 3, when it gets to 3.0001, it's okay. The next one is okay as well. It's just getting less precise. So all in all, we get back to this graph, we can see that the sad face is right there at x equals to 3 because it's undefined. So based on above, limits is an y value, and so it's an output of a function, and the limit is a real value. The third one is just the concept of the limit, which is it gets closer and closer but not touching. And the last one is that the limit may or may not be reached, which means it is either a number that was shifted away or a blank hole. If it is a number, we can see at this case when x equals to 0, the y value is gone to the y equals 2. So if it's a hole, it's just the case we talked above, that there's a hole, like a set phase right there. It is not defined, undefined again. So there's no replacement for that, it's just a blank hole. So anyway, thanks for your watching, and I hope you enjoyed it, and thank you, Mr. Brown.